Hi, everybody. Mr. Hayes, we're back. We're hitting the second part of figuring out how to do the test for a difference in proportions. We're formalizing all four parts here. This is the last little step. You've got a couple of days as we talk about some smaller, more nuanced parts of doing significance tests to practice this up. So I would highly encourage you guys to do at least one of these a day just because it's going to be very helpful. The more you do it, the more used to you're going to get. And I have all these things set up in scripts down below, I believe. And I also have, what else? The notes are like this for this are down below, and the links are down below, and the subscribe button's down below, and the like button's down. You get the idea. All right. So here are the 4 steps to doing a test of difference of proportions. First of all, again, state, plan, do, conclude. And why are we doing this? Because we need to come up with a good, firm, solid way to make it explicitly clear about what we're doing, how we did it, and what the conclusion is. All right, so P1 minus P2 is the true difference in the proportions. Again, make sure you add context on this. Your null hypothesis is going to be, and I also forgot, this is supposed to be the alternate hypothesis. So anyway, so P1 minus P2 is 0. P1 minus P2 is either greater than, less than, or not equal to 0. You're also going to, in the state section, state what your alpha level is. How fine are you going to try to get to make sure that nothing is happening by chance? You're going to state out your plan. You're going to say what type of test we're doing. So in this case, we're doing a 2-sample z-test for P1 minus P2, or you can say difference of proportions. And we're going to check the conditions. The other thing which you may want to do here is, or up here, is say which proportion is which. So I'm going to do this minus that. Here's my do. The z-score is really nice and cumbersome up here, and I say that somewhat sarcastically because we know that this looks a lot worse than what it actually is. This is the difference that we got from our sample. This is always generally going to be 0, though there are times where you're looking for a fixed difference, that this always has to be 5% more than the other one. And then down over here is going to be your standard deviation. So notice here we're using P of the probability or the proportion of the combined setup. And that's where the little c is there. So we're going to add the number of successes divided by the total number of samples. And you're going to use that also for large counts, which is going to be back here when we check our conditions. And then to conclude, you're going to interpret your p-value. So again, you're going to say, assuming the null hypothesis is true, what we're seeing happens at this probability purely by chance. And then you're going to say, what's the decision and what's my conclusion? So therefore, do we have enough evidence to reject it? And if so, what does that mean? All right. So here's another example. And this one is talking about, do preschool programs for poor children actually, what impact do they have? And so they're saying, let's take a look at, we're going to take kids who've never been to preschool. We're going to put some of them in preschool. We're going to keep some of them at home. And we're going to see how many kids long-term need social services to some extent. So they follow them for then 10 years after that. So from here, we ended up having researchers randomly assigned 62 to attend preschool, paid for by the state budget, and 61 to serve as a control group who would not go to preschool. One response variable of interest was the need for social services as adults. Over a 10-year period, 38 children in the preschool group and 49 in the control group needed social services. So those are going to be our proportions. P1, which is the preschool group, 38 out of 62, so 61% of the kids needed social services out of that group. The kids who were staying at home, P2, that one's 49 out of 61, is 80%. So the difference between those is a negative 1.9. So then they're going to ask you to go through, and does this provide convincing evidence that preschool reduces later need for social services for children like the ones in the study? And justify your answer. So whenever they ask you for the evidence and they ask you to justify it, guess what? 4 steps, okay? You're going to state, you're going to plan, you're going to do, you're going to conclude. And you're going to lay out all those different parts. Because by laying out all these different parts, you're not going to miss anything. Anyway, moving on. So take a swing at this, hit pause, and we'll check your work right now. All right, so speaking of checking your work right now, here we go. So your state step, P1 minus P2 is the true difference in proportions of children who will need social services, and we're doing preschool minus control. And that's where I kind of said above where you want to state which direction you're subtracting things. Our null hypothesis is that there is no difference. It's going to be the same, P1 minus P2. 0. What we're seeing here, however, is that there is a difference. So we're going to say P1 minus P2 is actually going to be less than 0. So that's what we're going to come up with. Alpha value of 0. And we up here, just so it's out of the way, come up with our combined proportion. So we added the 38 kids from the preschool group and the 49 kids from the kids at home to the total number of kids who were tested, who were taking the top is how many kids needed some sort of social service divided by the number of kids totally in the study, and we got 71%. So that's going to be, if nothing's going to be happening, this is what we should be seeing. And we're actually going to talk more about that when we hit chi-square testing later. So anyway, here's your plan. We're going to do a 2-sample z-test for P1 minus P2. That is an ugly 2. Looks like a 7. So check your things. It's randomly assigned. We don't need our 10%. Why do we not need 10%? Because we're not sampling. We're doing an experiment, so we don't need to have to worry about that. And then let's check normalcy. So for normal, we use large counts. So 62 times the 71% gives me 44. Same thing down here, get 18. In the other group, something similar. And all of them are bigger than 10, so we are good to go. So we have randomness, so we can extend it out. We can choose causation. We don't have to worry about our 10% since we're not sampling without replacement. And we have 10%, so we can treat everything as normal. Again, good things to keep in mind while you're doing it. So here's our do. So our test statistic, we write out the general form so that we're showing that we know what they understand. We write out what the actual formula is so we can show what we're plugging in. We've got a negative 19% minus 0 divided by our standard deviation. All of that turns into 0.082. So we're getting a negative 2.32. And as I said before, if you're over 2, you know that these wings are going to be 5.5 or 2.5%. So we know that we're already under 5%. We just need to know specifically how much. Because again, that also may allow us to, have even more evidence depending upon how small it is. So we've got our picture down here with a very poorly drawn little right side of the normal curve here. My apologies. Negative 1.9 is our, it should be negative. The point should be there. We'll just rewrite it there. So we're going to do everything lower than that 19%. So our p-value when we get this out is 0.0102. So about 1% chance of what we're seeing. Now what happens if it falls in that 1%? That's what we're talking about in the next video. How's that for a teaser? But here's our conclusion. So assuming that the null hypothesis is true, that there is no difference between P1 and P2, that the difference is 0, there is a 0.0102 probability of getting a difference of a sample proportion of negative 0.19 or lower purely by chance. And that's what this picture helps you decide. It's like, which direction am I going, the setup, etc. So because of that, so here's our decision. Because 0.0102 is less than 0.5, that's being our alpha value, we reject the null hypothesis because this is significant evidence or convincing evidence that preschool does reduce the later need for social services for the kids in this population. And again, this is the type of thing, if you're trying to fund your preschool program, you want to take to the state, saying, hey, this is going to have benefits for these poor children, the poor children who are from low-income families in Michigan, okay? This is the type of thing that if you're understanding, and even if you're not the one running it, you might be presenting stuff like this. You need to be able to sound like you know what you're talking about. And the reason why you're going to sound like you know what you're talking about is because you do know what you're talking about. So anyway, that it is, you have now done everything with confidence intervals and significance testing for proportions. We're going to hit a couple of different little nuanced things the next two, and then I'm going to guess you have a test on this. So again, go back, rewind, watch, leave questions down below, talk to your teacher, all that other good stuff. We will see you soon, and we'll talk about what happens if we actually have a study and it ends up down over in this section. What does that mean? What impact does that have? What is it called? So we'll talk to you soon.